Hello guys, today's question is find the closest element in the BST. We have given in the BST an integer k. We have to find the minimum absolute difference between the element we have given and the element present in the BST. What I mean to say that we have to find such element in a BST whose absolute minimum difference with the given element k is minimum. Here, as you see from the example 1, the k is given 30, the given integer is given 13, and we have to find such element in that BST so that the absolute difference between 13 and that element that we are finding in the BST is minimum. Okay, let's see what the answer. If we look at the example 1 BST, we have given elements 10, 2, 11, 1, 5, 3, 6 and 4, and we have given the integer 30, and from the layman method we can find that the answer should be 11. The answer should be 11 because if we calculate the minimum absolute difference between 13 and 11 and 2 is 2, and this difference is the minimum difference among all the elements present in the BST. Okay, now let's see the second example, how the second example performs. uh, if we see second example, in this question we have given an integer k is equals to 9 and that BST. If we closely look to that BST, the element 9 is itself present, and we know that if an element is itself present, then the minimum absolute difference between is 0. Between same elements is 0. Okay, uh, yeah, that's perfect. And now we can see the time, and the time for that question is big of h and big of h. It means that we have to do this question in big of h time, and h here specifies the height of the BST, and we can also use space which is also equal to the height of the BST. Now from that time and space, what institution is coming to your mind? Intuition is coming to your mind. From that, I have to think about knife solution. When you have BST and big of n and big of n space, this is knife solution BST. I can do in order traversal. According to me, I can do in order traversal, and I can do in order traversal, and there's an interesting fact in BST that when I do in order traversal in BST, I always get sorted order array. Okay, through which I can easily find the minimum absolute difference between the BST elements and the given integer k. So this is a naive solution, but we don't have to do this question by the naive solution. So we have to do with the advanced method. So what advanced method can we pick from these? From the hint. Actually, I will give the hint. That there's a, you know the hint. Okay, first there's a property in the BSC that the left element is always smaller than root and the right element is always greater than the root. The left element is always smaller than the root and the right element is always greater than the root. Okay, by using this fact we can easily solve this question. By this fact only we can solve the question. By using this fact, how we can solve the question? Let's come up to the whiteboard and solve this question by ease. Okay, now for whiteboard I have cut the first example. Now what this example states, as you all know, that we have to find the minimum absolute difference. Okay, so what intuition I can build from that BST property there? Look, that I have given element 13. Okay, now how I am thinking that firstly I can subtract the things. How? So there are two conditions to move our pointer left and right. And how? The first I will talk to the first condition. Suppose uh, element k is already given. Suppose while traversing the BST, we find the an element in the BST which is smaller than k. Okay, smaller than k. BST element. By taking this example, suppose from we are dealing with that question. Firstly, from the 10 we go to the left side, and here's 2. Okay, and we know that 13 is greater than 2. Okay, so there are two conditions through which by which we can travel left and right in the given BST. Suppose uh, in this by solving this example only we can understand the question properly. How we have given the K13. Okay, now our pointer is on 10. Okay, now how we will decide that how we have to move left or right? How? By simply using the property of the BST. Suppose uh, we are checking. First we check. Okay, how we check? Let's see. K is greater than first condition if K is greater than the BST element traversing. BST element. While traversing, we go through a BST element if it is greater than if it is smaller than K. So where we traverse? On the left side or the right side? We will traverse through the right side. How? I will explain. See, in this example, while we have given a pointer on 10. Now we will travel. We are checking that we have to move left side or right side. So for the checking of the left side, we are doing that K is greater than BST. If it is true that 13 is greater than left side, firstly we are in the left side of this pointer, left child. Okay, 2. Yeah, this is greater. If this is greater, 13 is greater than 2. So see, if 13 is greater than 2, this is a BST element. Can there is a possibility that we can find a much closer element with respect to K on the right side of this root element? Again repeating it, we have go through 2 which is smaller than K. Okay, can we have a chances that we can obtain a closure element with respect to K on the right side of this? Yes. If we go to the right side of this, we get 11 which is closer than 2. That's the main pick of this question. What I am telling that if you go through that condition, that if you're while traversing, if K is greater than BST, if K is greater than BST, then you have to traverse to right side, because there is a high possibility that the closure element is on the right side, because we know that K is greater. K is greater. 13 is greater than this. So as a is greater than this. Okay. As a BST property, we know that the other half, the right side of this element will contain an element greater than this. So it will be high possibilities that this element is much closer to 30 and will get the least absolute difference. Okay, and similarly, how we can decide we have to travel through right side? If K BST, if K is smaller than one of the element in the BST while traversing, then we can definitely predict that we have to go to the left side. How? I will explain. Look, suppose for example, in this question K is given 1. Okay, in this example K is given 1. So how will you traverse? Firstly, the pointer is here, so you will check these conditions. which condition is satisfying. K is greater than BST, or K is smaller than this element of the BST, current node, current pointer of the BST. Okay, this condition, second condition satisfying. Okay, so what we will do now, we will travel through right, left. Why left? Because we are getting an element. We are getting the element which is greater than the K, which is greater than the K. I am emphasizing on these words. I am speaking slowly because you have to listen these words carefully so that you can understand this question properly. Okay, the given number 10 BST element. This is the BST pointer, current pointer of the BST element is greater than 1. Okay, so there is high possibilities that if suppose if I will go to the right side of this 10, we will get more greater element than 10. So how this element is closer to 1? So there is high possibilities that in the left side it will get us closer element with respect to K, and we are getting like left, that is 2, in the 2. So we traverse to left side. Now we are in the pointer 2, where the current will in this version. Okay, now we again check it. If we again check it, where we will go in the first condition, second condition, we will again go in the second condition. Why? Because as you can see from this example, there's one, again the BST element is greater. If the BST element is greater, then there is a high much possibilities that the closure element with respect to K is found in the left side of this BST. And similarly, if the BST element, the current pointer element is smaller than the K, there is high possibilities that it will find on the right side. Okay, by these examples, by these two conditions, we can easily do this question. Okay, now let's go to the coding part of this question. Now, coding part of this question is like that, very simple. Firstly, we have taken a variable int max, that is equal to int max, in which we store the minimum absolute difference. Then we are running a loop while root is not equal to null. We are storing the every absolute difference through which we are traversing. We are storing every current pointer difference, minimum absolute difference in which we are traversing. Like that, if we find the root data is equal to K, then we will return 0. If it is root data is greater than K, then we will move to left. If it is smaller than K, we will move to right. Through this traversal we all store the res variable so that we can find the answer, and finally we return the answer. So thank you.